what I'm going to discuss today is GenAI's future among ADAS, AV data labeling best practices. Just a couple words about myself, so you actually know who's speaking. My name is Johan Scherbart. I'm in charge of automotive. I'm the director in automotive for Sama in Germany. I'm leading all our initiatives in the automotive space. Last 4 years, I've been exposed to multiple 2D, 3D validation workflows. And today I would like to talk about best practices, data labeling as of today, and how GenAI could help in the future. Before we start, anyone knows what this is? Yes? No? Okay, I won't make it too long because everyone is hungry. It's a meat hook used in the meat packing districts to hang the meat. Any idea why I'm showing you this? Not to gross you out before you go for lunch, I promise that. When Henry Ford started to produce cars, the demand for his famous Model T grew and grew and grew, and everyone wanted him to produce more cars and quicker. So when he passed by the meatpacking district in Chicago, and he saw how they were using those specific hooks on the assembly line to dismantle the meat, he saw an opportunity to speed up his car production. That was basically the creation of the moving assembly line that we're still using today. He found this expertise outside of his own expertise in the meatpacking district. The car he built did not change. What changed was the process behind it, which allowed him to produce more cars faster and more efficiently as the demand was growing. The famous Model T and the affordable Model T changed America's landscape entirely, and the moving assembly line triggered a new industrial revolution amongst factories around the world, until today. Which brings us to today. Software, AI, GenAI is changing the way we're interacting with our cars entirely. Data is the main ingredient that drives this revolution, and I think we need to find new ways or hooks to see how we can use the data more efficiently and in a better way as the demand is growing. What I would like to discuss today, again, is best practices in AV, ADAS data labeling, discuss their pros and cons, and then have a quick look in the future how GenAI could help here. I will not tell you which approach is the right one, because there's no right or wrong answer. It really depends on your personal data strategy and your workflow. What I would like to have, if we have a little bit of time, is an open discussion that hopefully allows us to find one or two hooks that will allow us to deal with data in a better way. Autonomous driving had its reckoning last year. Several programs were stopped and questioned. I think one of the main challenges in our industry is that we need to find every single edge case. We need to detect and recognize and classify every object that's of interest, and that really caused a spike in data, a massive amount of data that has been poured into these neural networks. On top of it, the cost of data collecting, storing the data, pre-analyzing the data, labeling the data, and then combine this with the always present time pressure in our industry has really caused a shift towards fully automated systems that really resulted in a lack of quality and underperformance of several models for certain function and features, which was one of the reasons why so many programs were delayed or actually stopped. So let's have a look at the current trends in data labeling that we're currently using, right? Let's start with the oldest one, human in the loop, right? Human in the loop can actually close the gap between fully automated system and actually producing high, meaningful data. What are the pros, right? Involving trained, skilled human in the loops results in higher quality. If you have a human loop workforce that has been trained properly, they understand the quality requirements, it will benefit your data set. Next one is humans can make critical decisions. They can manage edge cases and complex driving scenarios where fully automated systems are prone to fail. It provides flexibility. If you have a very skilled, trained workforce that is embedded in your workflow, they can provide you a lot of flexibility. You want to ramp up, you want to ramp down. You have changes in your requirements, you have changes in your labeling guide or quality, you have issues getting your data in on time. they can really accommodate that and work around you, provide you the flexibility that you need. Last point, which is super important, creating confidence in responsible AI. We're all working here on life-saving features and functions. Human-in-the-loop can erase biases in the data set and actually increase transparency, and this is what we all want, right? What are the cons? Well, training time for a human-in-the-loop approach for complex workflow might take a little bit longer. If you have a complex 3D sensor fusion workflow, multi-sensor setup, dynamic objects, vulnerable road users, tracking everything over a longer sequence, it might take you a little bit to get there. But if you have a good supplier and if you have a good labeling guide and actually really good data, it's possible. Finding the right mix between human-in-the-loop and automation, right? This needs to be planned properly because otherwise you risk having a lot of bottlenecks and to do repetitive work, and that's not the goal of it. Requires close alignment and commitment from both sides, supplier and the customer, to really get those rich benefits of higher quality. What would be a good example for using human-in-the-loop? As I said, 3D workflow, sensor fusion, vulnerable road users, dynamic objects, tracking object over a longer sequence, focusing on a specific region of interest. You definitely want to involve a human-in-the-loop approach here. Definitely you can use a pre-labeled data set to annotate the static objects, but just doing this through a pre-labeled data set won't be sufficient enough. So this would be a prime example for using human-in-the-loop approach. Since I already talked about pre-labeled data sets, well, the second omnipresent trend in data labeling, pre-labeled data sets, right? Right now, they're on the rise again in the industry. A lot of people are asking for them. What is a pre-labeled data set? Well, a pre-labeled data set is basically the outcome of a machine learning approach to automate labeling and detection of objects. That's mostly done by taking a subset of a ground truth data that has been accurately validated, labeled and validated by a human-in-the-loop approach. Goal is to really have a very specific, tailored subset that can be used for simpler workflow to really speed up production and get good insight into labeling. What are the pros? Well, great way to pre-select data and to train a model. If the model is comprehensive enough, it really allows you to generate good results and speed up your labeling progress. As I said, for 2D workflows or for 3D workflows, static object, it works quite well. So it allows you really to start your labeling, your data pipeline, provide data to your feature teams when you spend a little bit more time training on edge cases and complex driving scenarios. Good for maintaining a high-quality data set. If you have a reoccurring data set that is simple enough, let's just run it through a pre-labeled data set. It will provide you good data and keeps everyone in your organization busy. You get your KPIs. That's perfect. Yeah, what are the cons? Many ADAS cases, pre-labeled data is not good enough. We have a baseline of 95%, and currently we don't have projects that are under 98% quality. Pre-labeled data sets are not good enough for this. Increasing taxonomy in our workflows, right, is really pushing those systems to their boundaries and actually causing a lot of questions and doubts in them. High cost of maintaining and developing. Beginning, it always looks like it's cost saving, but running the data, generating data, updating it, maintaining it, developing new algorithms, storing the data, cloud cost, that needs to be considered before using a pre-labeled data set. And at the end, you still need a specialized team of manual validation to ensure quality in the data set. You also miss a critical component, which is a human loop that can make a critical decision on an edge case and a complex driving scenario. Also, if those systems are not developed properly, they're prone to systematic errors. If you have systematic errors in your data set, well, that's a whole different ballgame. What would be a good example? 2D workflow here. We have on the left side the COCO 2017 open data set. We ran this through our system. In the middle, Sama COCO. On the right side, you can see how much better the annotation already is. That's what I'm saying. Simple workflows, static objects in 2D, 3D. Use pre-labeled data to speed up your production, to get data in, to have a constant flow of data. That works perfectly. Next, the buzzword that everyone has been using, including me now, GenAI, large language models, and computer vision. I think since the introduction of ChatGPT, the entire world is now focusing on GenAI and large language models. Large language models are changing the way we use data, right? We see this with all the chatbots, the rise of virtual assistants everywhere. This is happening as we speak. I think we can all agree to this. I think for us here, for automotive, what we need to find out in the future is, number one, are large language models, especially multimodal large language models, a right fit for autonomous driving? Number two, are they sophisticated enough to provide personalized and comprehensive results for complex driving scenarios? And can computer vision and LLMs actually be combined? This is something we need to find out in the future and try use cases. But let's have a look at the pros and cons here. What are the pros, right? Answering context question. You get more context behind a scenario. Providing reasoning for scenarios. If we're driving on the street and all of a sudden a ball rolls into the street, you and I, we immediately go on our brakes because we assume a bunch of kids following the ball. Providing that extra layer of safety for all those functions and features, I think would be quite wonderful. Relationship between images and text to learn. For me, that's always fascinating, right? If you think about how we learn as human, right? When we're little, we look at images, pictures. We get a little bit older, we get like the single word to connect with the object. We go to school, we learn how to write, to read a little bit more books. Go to university, we start reading research papers, we watch videos, podcasts. That rich way of learning could definitely benefit in a model. Using LLMs for the requirements management. For me, this is one key area, right? You have so much data, historical data. I mean, if we're working on a workflow, everyone knows, right? You get this SOW or the labeling guide on your table is like this thick. So all this data that has been stored. If we can combine this, I'm pretty sure that will benefit every project. And then help with recognition and classification. I think that's one of the main reasons we're collecting all of this data, because we want to recognize and classify every object that's of interest. If there's ever a case where your model or a system decides to not recognize or classify an object, well, it just ignores it. If that happens, and it's a really bad scenario, it leads to one of those headlines you then read in the newspaper or on social media, and we don't want that. So if we have an extra safety layer that can help here, we should make use of it. Fine-tuning of LLMs was made accessible last year. You have multiple plugins, applications that now allow you to pre-train a subset of a generic large language model, which could allow you to really work on different use cases, having different subsets. Very interesting. What are the cons? More complex than just prompting text, right? You combine multiple models. Latency in the prompt. If you ever put something into ChatGPT, it takes a little bit to give you a result back, right? We don't have that luxury in driving. A second can be very long, so you need to have instant responses. Hallucinations. We don't know how they're going to affect overall model performance if you combine multiple models. We need to find out. Costly. If you think having a pre-labeled data set is costly, training just a generic large language model is very costly. The amount of data that is required, the training, the development, so that's a decision that needs to be planned properly. And then the RAG, right? The RAG is getting more complex, combining it multi-models, so it definitely requires an additional layer of human in the loop to ensure quality and accuracy. What would be a good example here? This is from Ghost Autonomy in America. They have a partnership with OpenAI. They're using large language model to make, for reasoning and also for classification and recognition, especially for vulnerable road users, to make sure they're not missing any object. Everything is recognized, so they don't have a case where, something is just ignored. I'm very curious to see where they're going to head in the future. For me, this is one of those prime examples where you can literally use large language models to provide an extra layer of safety, because the scenarios we're trying to solve right now, they're getting more complex, so we should make use of everything that can help there. At the end, I think we can agree, right? Large language models are fairly new. On the other hand, the acceptance in other industries, also in automotive, is rising and rising. So I think personally it's just a matter of time until we see more cases in the automotive industry. As I said, I'm not going to be too long today. So what did we discuss today? We discussed human in the loop, pre-labeled data, and large language models and computer vision. What do we have as of today? We have the human-in-the-loop approach that really can overcome the constraints and limitations of only using a fully automated system, actually providing higher quality, accuracy, and meaningful, unbiased data. Then we have pre-labeled data sets that really allows us to tackle those large data sets, get a very quick insight into those data sets, and really taking the repetitiveness away from a human in the loop. What does the future hold? Well, as I said, some argue that large language models are not designed for this type of work, that they're actually going to be less effective in autonomous driving. But let's assume for a second, large language models and computer vision can be combined. What great opportunity that could be, right? Maybe that's one of those new hooks that we can use to change the way we're doing our requirements management for data labeling and data collection. Maybe it will allow us to be more efficient there. Maybe it allows us to connect the entire V model, from requirements to validation, software, safety, together with supplier data, customer data, internal research data, sensor data, to really allow us to train and deploy those functions and features in a better way, and to erase data silos within projects and organizations. Fine-tuning LLMs will maybe help with the development of pre-labeled data models, makes them more accurate, more efficient. Maybe large language models makes them completely obsolete. GenAI could help with the training and feedback for human-in-the-loop, providing them more insights so they can reach their quality goals quicker and learn better. GenAI could provide more details about each single data point for a edge case by providing more context and reasoning, so we have a better overview about overall model performance. Large language models could provide reasoning for a human-in-the-loop to make a critical decision on an edge case or complex driving scenario. I think at the end, right, if computer vision and large language models can really be combined, and they can overcome the ongoing issue of recognition and classification, that could really change the way we're going to deploy neural networks. It could also allow us to have a more sustainable way of collecting data and not flooding the neural networks with too much data that actually also makes them vulnerable. So at the end, done right, your data initiatives can positively impact your models as well as the world around you. What we're offering with our customers is a mix, a combined mix of everything. The human-in-the-loop is a strong focus of ours. We have built-in machine learning functions, pre-labeled data sets, and GenAI offering. More than happy to discuss this with everyone later at the booth or during lunch, where I'll let you go in like a couple seconds. Thank you so much for letting me speak. It's been an honor. Thank you so much.
Okay, do we have questions from the audience?
Everyone hungry?
I will fill in the gap until they... So one topic that is interesting for myself is the topic of explainable AI. Mm-hmm. And listening to your talk, it gave me an idea just to ask this. Do you think this kind of GenAI approach could be used to train humans to be better at their job and to explain them what they've found and what kind of tips and tricks as a feedback loop could be given to humans? So just to be better in their jobs, to have shorter onboardings, shorter trainings to do their job, and to have overall competency increased.
Yeah, good question. I think if you look like how you train them, right? You get a lot of data from the customer, you have some historical data, but sometimes you're looking for the needle in the haystack when it comes to quality, right? And it really also depends on the workflow. So if you have a system or background that really highlights those edge cases, gives you like a little nudge to have a closer look, and that probably saves you a couple days or sometimes a week to really train them and get them to the next quality peak, I think is super beneficial. And again, it will take away a lot of repetitiveness, going through all the paperwork, looking for a specific thing, feedback loops back and forth. I think, that's one of the reasons where GenAI could really help and support the human-in-the-loop.
Okay. Great. Do we have someone? Oh. Yeah, we have a question.
Hi.
Thank you very much for the talk. Quick question in regards to pre-labels. Do you foresee pre-labels as input for those LLM, etc.? And if so, does it bring any risk of bias on those models that you produce, right? Because you are, in the end, but there is a benefit for sure using pre-labels as an input for your models,
Yep.
vice versa. So how do you see that?
Yeah, good question. I think that's something we also need to try out. At the beginning, I wouldn't use pre-labels to feed the LLM. Maybe vice versa, right? Based on text reasoning to support the pre-labeled data set to recognize, classify an object. But then at the end, there's something we definitely need to find out. Thank you.
Hi.
Hi.
I have a rather short question. I was just wondering, you were saying that your data set reaches like, I will take it or not, reaches like over 95% of something. I guess you mean like the accuracy of your data set, and how can you check that if you like, of course, if you know the ground truth, then every human goes through in the loop and checks everything, then you can say. But how can you say without checking every single frame?
Good question. Just to classify, it's 95% is our baseline. So that's the quality we're offering. The projects we all see right now are at 98%. Just to break it down simply, if we have 98%, I do 100 images for you, only 2 can be wrong. The way we measure it, we have customized quality rubrics. We check certain batch sizes. We have inbuilt tracking devices in our platform that does automated pre-checks before it goes out. So that's how we measure the quality before it goes out. So it's a mix of a human in the loop and automation together. Answer your question?
Yeah, but so you still need a human base, like
For the quality we're working in, yes, 100%, yes.
Okay.